So, tonight we're going to talk about our second natural argument for the existence of God. But before we do, I'd like to take a little detour. And I told Meister that I was going to pick on him, and now he's not here. But a couple weeks ago, he came to me after class and said, what do you say to somebody who says they won't believe in Christianity because there's so many denominations? And, we were talking about that, and I thought, this is a theological question. It's a church history question. But the thing that makes it an apologetic question is the fact that someone's using it against the faith. And so I told him, if it were me, I'd start by saying, some of the differences between the denominations aren't that big a deal. It's not to say that they're unimportant, but there are denominations that are very, very similar to each other. And I also said, you should emphasize that there is a core to Christianity, and as long as you believe those specific things that you need to believe, you're a Christian. So, for example, a Nazarene church would be very different from us in how they do baptism, even communion, what they think of eternal security, salvation, things like that. But we would still think that those people are saved. And, I didn't say this at the time to him, but I thought, think of that opportunity. Because 2 weeks ago I mentioned, apologetics isn't necessarily evangelism, but they're related. But you don't get people saved by giving them a really great argument. You get them saved by giving them the gospel. And so as I was thinking about it later, I was like, he could really start to answer that guy's question and then pivot and say, this central core that Christianity has is that people are separated from God because of the bad things that we've done. And that's why Jesus had to come to earth, live a sinless life, die on the cross, and rise again to pay the penalty for that. And then anybody who puts their faith and trust in that becomes a believer. They become a Christian. And then after that, you get into the denominations. Now, you could probably tell that to somebody, and they wouldn't even know that they're being evangelized. But that is the gospel. But the conversation naturally flows like that. And I think a lot of times when we think of evangelism, we think of those Ray Comfort videos where he just walks up to somebody on the street, says hey, what's your name? Okay, cool, let's talk about Jesus. And that's cold evangelism. Nothing wrong with that. He does a really great job with that, not making it awkward. But I think evangelism is obviously more than that, getting to know people, talking to people, etc. And I remember a time where I was talking to a girl who wasn't a believer, and she just asked the question, somehow we got onto the topic of Catholics and Protestants, and she was like, what's that all about? And so I talked about church history, told her about Martin Luther. I told her how Martin Luther was really struck by that verse that says, the just will live by faith. And that kicked off the Reformation. Went through some of the solas. I didn't go through all 5, I don't think. But talked about justification by faith, by grace through faith, through Christ. And basically gave her the gospel. And like I said, I don't even think she knows she was being evangelized. So I'd like to encourage you with that very first question that I asked, how do some people come against the Christian faith? Maybe this week, just think about that. How would I have a conversation about that? Not just answer their question, but also kind of pivot to the gospel. And it can be tricky. My last example, I don't want to beat this to death, but my last example, I was talking to a young lady about abortion, and I still answered her objections. She said that she thought it was a woman's right. And I pointed out that the vast, vast, vast majority of babies aborted worldwide are usually girls because they are less desirable. So yes, it is a woman's right. Or it is a woman's issue because those female babies are being aborted. And she said, well, the unborn, that's just a fetus. That's not a human person. And so I said, well, what do you think a fetus is? And we talked about that, and I actually got her to admit that the unborn were human persons, that it's wrong to kill human persons, but she still said abortion should be legal. And when I pointed out that she was contradicting herself, she said, well, I'm allowed to contradict myself. And I kind of described to her what happens during an abortion, and that you can watch one online via ultrasound. It's very disturbing. And she was so disgusted by the end of it that she didn't even want to talk about it anymore. And then I just kind of said, I'm offended that that takes place in our country as well. But because I'm a Christian, I know that even the sin of killing your unborn baby is not enough to keep you from God. And did you know people are separated from God? And that's why Jesus had to come to earth, and we were off and running. So that's your assignment for this week. Just think of those arguments that you brought up, and think about how you could bring it more towards the subject of Christ. Okay? So tonight, we're going to talk about the teleological argument. If you remember from last week, we talked about the cosmological argument, which is the argument from the beginning. Now this one is, since we have the universe, are there things about the universe that we could look at that would point to maybe this universe is designed? And teleological just comes from the Greek word telos, which means goal, purpose, or end. And so it's just a fancy way of saying design argument. And on the board here, I have 4 different teleological arguments. And if you're like me, when I first found out that there are like families of apologetic arguments, I thought, oh, great. This is like denominations applied to apologetics. And there actually is some of that, but that's not how this works. You could use any one of these. You could use all of these together. They just focus on different things. They kind of answer certain objections that maybe one other argument would be a little bit weaker on. So the first one we're going to talk about what's sometimes called the Goldilocks principle. And this is just that the earth is a habitable place for life. And so if you did your reading, or if you would like to read, this is basically the entire chapter 4. Next, we'll talk about fine-tuning, which that one's my favorite. And actually, when I was studying for this talk, I came across a video where Christopher Hitchens, who was a famous atheist, he was asked, what is the best argument against your position? And he said the fine-tuning argument really makes us stop and think. Unfortunately, the book only gives one fine-tuning argument, but I'll give you some resources for that as well if you'd like to look into it even more. The third one is design as biological information. In the book, this is chapter 5, so you're basically talking about DNA. That one's also fun, but we'll just kind of touch on that one. The fourth one is the argument from discoverability. Our book does not talk about that, but again, I'll point you to some resources if that's something that you'd be interested in. So here's the teleological argument as it appears in our book. Every design had a designer. The universe has a highly complex design. Therefore, the universe had a designer. There are some people who say you actually can't detect design. It's almost like design is in the eye of the beholder. And over the next couple minutes, I want to show you why that doesn't quite work. So here is a picture of the Old Man of the Mountain. And this was a tourist attraction in New Hampshire. And if this looks familiar, it's probably because you've seen it on the New Hampshire $quarter. Unfortunately for the state of New Hampshire, 3 years after this quarter was minted, the Old Man of the Mountain fell down. So now nobody goes to New Hampshire because there's no reason to. But you can see, this looks like the profile of a man. You've got the nose, you got the mouth, you got the chin. You might be able to argue that that's designed, but really, it just seems like a coincidence. It just kind of looks like the profile of a man. Now, another tourist attraction that you're probably familiar with, here's Mount Rushmore. You could say that Mount Rushmore came about through wind and erosion, just by chance, and I'm sure people have sat down and figured out the probability of Mount Rushmore coming together by chance. I actually watched an apologetics class where he said his chemistry professor did the math to figure out what are the odds that all of the molecules in Mount Rushmore would be vibrating in such a way that Mount Rushmore could jump 8 feet in the air. And he said it is possible, but it's never going to happen. But obviously, even if you don't know how to explain it, you know that the one on the right is designed. Even if you didn't know who those men were, you would know those look so much like the faces of men that there's no way that that came about by chance. An even simpler example, on the left you have an arrowhead, and on the right you just have a rock. Now you could take these into the lab and run all the tests that you wanted, you would find out that these are made out of 100% the same stuff. But you can see, with the arrowhead, somebody manipulated that. It looks like other things, like a flint knife or a spearhead. It's not just a rock. And that's actually a defeater for people who say that you could never detect design. If that's true, then you would never have archaeology. You would never have forensics, crime scene investigation, things like that. So there are a number of criteria that you could look at to figure out if something is designed. Here are just 4 that I got from J. Werner Wallace. If something resembles a known design, the odds are slim that it would come together by chance. It serves a specific purpose and is directed towards a goal. So back to the argument. The first premise is the easiest because it's pretty straightforward. You just establish if something is designed, it has a designer. Much like last week, the heavy lifting actually comes with the second premise. So the universe has a highly complex design. How can we tell if the universe is designed? We look for things that resemble design. The odds of it coming together by chance are slim, serves a purpose, and directed towards a goal. So for our first argument, this is the Goldilocks principle. So this is the idea there are many things that make life possible on Earth, and if they were a little bit one way or a little bit the other, we wouldn't exist. Probably the most popular example is the distance from the sun. Have you guys heard of this before? So obviously, if you're too close to the sun, it's too hot. And you can't have liquid water, and you can't have ice. So we don't expect to find life on Venus, because it's too hot. In fact, you can't have solid lead on the surface of Venus. It is that hot. But then if you go too far the other way, it's too cold. If there is any water, it freezes, so it can't be used. And we don't expect to find life too far away from the sun. There's a narrow band where you can be close enough to the sun to have liquid water and to have life. Now, to be fair, that narrow band is millions and millions of miles wide, but there's only one planet in that band. That is called the circumstellar habitable zone. And the odds of being inside that band are a lot smaller than the odds of being outside that band. Now, what a lot of people don't know is there's also a galactic habitable zone. So you can't be too close to the middle of our galaxy. There's probably a black hole in the middle. It's a little more volatile. Things are exploding in the middle. But you can't be too far away from the middle because you don't have the heavy elements that we need for life as we know it. Now again, the odds of being outside of the galactic habitable zone are greater than the odds of being inside. So now you're taking 2 probabilities and you're combining them. But it's not just the distance from the sun. We actually need a certain kind of star. And I've heard that, yes, there are trillions and trillions of stars in the universe, but the kind of star that you would need for life, like the kind that we have, is actually quite rare. And I don't want to go too much into this because we have a video that we're going to watch and they're going to talk about the sun. But just notice, it's not just the Earth that needs to be within these certain parameters, it's other bodies as well. But speaking of the Earth, we need a very specific oxygen level. Currently, it is at 21%. If it were to get up to 25%, the atmosphere could literally burst into flames. But if it got down to 15%, we would suffocate.
Is it moving a certain direction?
I think it's fluctuating, but it balances out. Carbon dioxide level. If we have too much, we have a runaway greenhouse effect. If we have too little, then plants can't photosynthesize. That one would actually be the one where people would be freaking out about the increase. We need a certain atmospheric transparency. If the transparency is too little, we don't get enough solar radiation. If there's not enough, then we get too much solar radiation. The moon is also very important. I heard an astronomer say that there are at least 20 things about the moon that are just right so that we can have life on Earth. And so just some examples. It stabilizes our axial tilt. It has to do with like the tides and our climate. But we also need the other planets. So a good example of this is Jupiter. Jupiter is huge. So you see the great red spot in the bottom left. You could fit the Earth inside that spot with room to spare. You could take every planet in the solar system, put it inside Jupiter, and you would still not have filled it halfway. Like, this thing is massive. And because of that, it has a more intense gravitational pull. And so if there are meteors or comets that could come towards the Earth and wipe out life on Earth, they're actually more likely to slam into Jupiter. And so the book calls Jupiter our cosmic vacuum cleaner. Now, I actually remember as a kid in the 90s, a bunch of asteroids hit Jupiter. And on the news, they said if they had hit the Earth, we'd all be dead. But because Jupiter is so large, it was like pricking an apple with a pin. There was like almost no damage. There are more things. The book talks about the thickness of the Earth's crust, the rotation period, the 23-degree axial tilt. We even need things like lightning and earthquakes. Things that we usually associate with death and destruction, we actually need those to survive. So this brings us to our first short video clip. This is, I'm not going to be able to do two things at once here. This is a clip from the documentary The Privileged Planet. And that documentary was made after a book by the same title. I have the audiobook. I think it's a little more technical. The documentary is a little bit easier to understand. But it was written by two men. One is Guillermo Gonzalez, which is seen there on the screen. He is an astrobiologist. The other guy's name is Jay Richards. He's a philosopher. And so I think it's kind of cool, like when the scientists and the philosophers team up, you know it's going to be a pretty wild ride. After that book came out, Guillermo Gonzalez was denied tenure at Iowa State University. And a lot of people think that it was because of his views on intelligent design. So if you recognize this guy, has anybody ever seen the movie Expelled? He was interviewed in that movie. So, but I like visuals, and this will give us some nice little animations to show how some of these things are finely tuned and, that whole Goldilocks principle.
I'm an astrobiologist, and the area that I've done the most work in lately is the field of extrasolar planets. What motivates me is just to examine the conditions necessary for life and look elsewhere in the universe and see if those conditions are met anywhere else. And the answer could be yes, and the answer could be no, and either answer is interesting.
Guillermo Gonzalez works as a research scientist in NASA's astrobiology program. His interest in this field is tied to his early fascination with the prospect of life beyond the Earth.
I grew up in the 1960s, and like most other people of my generation, I was really amazed by the Apollo lunar landings, and that really inspired me and had something to do with my getting interested in astronomy. In my early years, I came to believe very strongly that there must be other civilizations out there and that the galaxy was teeming with life. And so I was a strong supporter of the search for extraterrestrial intelligence. My belief wasn't based on any real hardcore scientific arguments. It was just the impression that I had that the galaxy was such a big place. And I didn't give the other side of the equation much thought. In other words, there's two sides of the equation. There's the number of stars, the number of trials, if you will. But the other side is the factors. It takes a lot of factors to have a habitable planet and a planetary system.
For Gonzalez and other astrobiologists, these factors, required for the Earth's habitability, became the focus of extensive research.
We've demonstrated in dozens of different ways the laws of physics and chemistry that pertain in a laboratory anywhere on Earth apply anywhere in the solar system, apply anywhere in the galaxy, and in many cases out to the most distant galaxies that we can see.
There are indeed unchanging physical laws in the universe that apply to the entirety of the universe, that they're not localized to one place.
This consistency in the laws of physics and chemistry has led many researchers to conclude that the factors necessary for complex life on Earth are also the best parameters in the search for habitable planets elsewhere in the universe. Most serious discussions about these factors begin with the same prerequisite: liquid water.
All the searches that are being done for life elsewhere, their starting position is a terrestrial class planet with water.
It is now widely recognized that the chemical properties of water are exquisitely suited for carbon-based life. These properties include water's ability to dissolve and transport the chemical nutrients vital to all living organisms, and its unmatched capacity to absorb heat from the sun, a process critical for regulating the Earth's surface temperature. In liquid form, water is an extraordinary substance, and its existence hinges upon another factor essential to complex life: a planet's distance from its home star.
It's like what they say in real estate: location, location, location. A habitable planet lives in what we call the Goldilocks zone. It's not too hot, it's not too cold, it's just right. And when I say just right, I mean just right for water.
Liquid water really helps define the habitable zone. If it's too hot, again, the water just boils away. You just can't get condensed water. It's too cold, as in Mars today, it freezes out.
Within our solar system, the habitable zone is relatively narrow, beginning well outside the orbit of Venus and ending short of the orbit of Mars. If the Earth were just 5% closer to the Sun, it would be subject to the same fate as Venus: a runaway greenhouse effect with temperatures rising to nearly 900 degrees Fahrenheit. Conversely, if the Earth were 20% farther from its home star, carbon dioxide clouds would form in its upper atmosphere, initiating the cycle of ice and cold that has sterilized Mars.
The presence of liquid water is a necessary condition for life, but it's not a sufficient condition. After all, there may be liquid water under the frozen surfaces of Mars and Jupiter's moon Europa, but there's very little chance that complex life exists in either of these places. You see, contrary to what the Copernican principle might suggest, the recipe for life is much more complex than just add water.
If a recipe for a planet capable of supporting complex life really did exist, then what ingredients beyond liquid water might be required? The list of necessary factors continues to grow.
We live on this paper-thin crust. If the Earth's crust were significantly thicker, then plate tectonic recycling could not take place.
The Earth's crust varies in thickness from about 4 to 30 miles. It consists of more than a dozen tectonic plates that are in constant motion. This dynamic geology regulates the planet's interior temperature, recycles carbon, mixes chemical elements essential to living organisms, and shapes the continents. Deep within the Earth's interior, the movement of liquid iron generates a protective magnetic field essential to complex life. If our planet was smaller, its magnetic field would be weaker, allowing the solar wind to strip away our atmosphere, slowly transforming the Earth into a dead, barren world much like Mars.
We need an oxygen atmosphere, and the oxygen-nitrogen atmosphere that the Earth has is necessary for complex life.
As seen from space, the Earth's atmosphere glows as a thin blue ribbon of light. Measuring less than 1% of the planet's diameter, it is composed of a mixture of nitrogen, oxygen, and carbon dioxide. As a result, our atmosphere ensures a temperate climate, protection from the sun's radiation, and the correct combination of gases necessary for liquid water and complex life.
For a size of planet like Earth, our moon is big. The current thinking is that if our moon didn't exist, neither would we.
1/4 the size of the Earth, The moon's powerful gravitational pull stabilizes the angle of its axis at a nearly constant 23.5 degrees. This ensures relatively temperate seasonal changes, and the only climate in the solar system mild enough to sustain complex living organisms.
If we find life out there, especially complex or even intelligent life, it will be around a star similar to our own.
We orbit what is known as a spectral type G2 dwarf main sequence star. It is well suited for our needs. If the Sun were less massive, like 90% of the stars in the galaxy, the habitable zone would be smaller. To remain within its boundaries, the Earth would have to be positioned closer to its star. Here, increased gravity would lock our planet's rotation into synchronization with its orbit. While one side of the Earth continually faced the Sun and increased radiation from solar flares, the dark side of the planet would lay shrouded in perpetual cold and ice. It is unlikely complex life could tolerate these drastic extremes in temperature.
A lot of things went right on Earth to have yielded complex life, absolutely.
The number of factors that have been postulated has grown. Currently, the typical number you would see is, in a typical list, would have something like 20.
We find that we need to be at the right location in the galaxy, that we're inside the circumstellar habitable zone of a star, that we're in a planetary system with giant planets that can shield the inner planets from too many comet impacts, that we're orbiting the right kind of star that's not too cool or not too hot, that we're on a planet that has a moon that can stabilize the tilt of its axis, that we're on a planet that's a terrestrial planet, a planet that has a crust that's just thick enough that it can maintain plate tectonic activity, but has enough heat in its interior that it's still circulating its liquid iron core so it can generate a magnetic field, that it has an atmosphere that has enough oxygen to allow for complex organisms to survive, that it has enough water and enough continents to allow for the diversity of life or an active biosphere that you need to support complex creatures such as ourselves. All these factors have to be met at one place and time in the galaxy if you're going to have a planet as habitable as the Earth, which you need for complex and even technological life.
In an attempt to estimate the probability of attaining this combination of factors simultaneously, some researchers have developed equations assigning a conservative 1 in 10 value to each factor deemed necessary for advanced life.
If every element has to be there at the same time, you have to multiply the probabilities. And that's what makes the probability at the end so small. You've got 10% of this and 10% of that, and these things rapidly multiply to exceedingly small numbers. The numbers on the order of 10 to minus 15, which is 1/1000th of 1 trillion. And it's a number like that that you have to compare to the 100 billion stars that are in the galaxy. 100 billion is a very large number, but 1,000th of a trillionth is much, much smaller. On their face value, these probabilities are speaking. What they're telling us is this can't happen, or this is very unlikely to happen in the galaxy. And that's where the evidence is pushing us.
There are many probabilistic resources in the galaxy, but on the other side of the coin are all these factors that you need. You have to get just right in order to have just one habitable planet like the Earth. And that leads me to conclude that yes, we're rare in the galaxy.
So they mentioned the other planets in there. There is an astronomer who is also an astrophysicist. He's also a pastor, and his name is Hugh Ross. And Hugh Ross wrote a book called Why the Universe is the Way That It Is. And he put an appendix in this book where he was just going to put a list of all the things that need to be just so to have life as we know it. And it was actually just a link to a website because he couldn't fit the list in the book, and he said that this list is going to be constantly growing. But I have a hard copy of this list, and it's over 400 things. Now, in the video they said there's about 20, but this is everything. Like everything for life, everything to do scientific experiments, everything to have technology, things like that. And it goes through, and it gives you the example, and it says if it was too far this way, this is what would happen. If it was too far this way, this is what would happen. So that's another thing when you start talking about design. Sometimes people, they try to tell you how many arguments there are, and you have to figure out, are they talking about life? Are they talking about intelligent life? Are they talking about technological societies, etc.? But if you want to look through that, I'll have that up here. So how would a skeptic object to this evidence? And usually the first thing you'll hear is something like, scientists estimate that there could be somewhere between 20 to 100 billion Earth-like planets in our galaxy. Like that was mentioned in the video. And when you take the estimate of all the Earth-like planets in the universe, it's 10 to the 22nd, which is 1 with 22 zeros behind it. There are that many planets in the universe, and many people say that there has to be life somewhere else. Now, the video kind of talked about this, but yeah, there's 10 to the 22nd planets in the universe, but you need more than just a planet. You need all those factors together. And the chances of getting another Earth like ours is 1 in 10 to the 38th. So that's a 1 with 38 zeros behind it. That's a massively smaller chance than there are planets in the universe. And I think you could make a good case that the Earth is quite rare. I've even seen non-believers make that case. We're probably the only planet with life. But I do think that this is kind of the Achilles heel of the Goldilocks principle, because there are people who just will not accept that there's not life somewhere else. I know somebody like this. Like, they're really into Star Wars, really into science fiction. There's all these planets. There has to be another Earth somewhere. Now, even if we could find intelligent life somewhere, I don't think that that would disprove Christianity. But I also think that when you look into the probabilities, it's very, very slim. Another common objection is someone will say the universe can't be designed. Just look at, and then they'll say something that they would have done differently if they were the designer. I saw a speech given by Neil deGrasse Tyson where he was just going on and on about how there can't be a designer. Just look at all this stupid design. And usually a popular one that you'll hear is people will say the majority of the universe is hostile to life. Why would the designer have all that wasted space? Now, I think this is kind of a bad argument for a couple of reasons. Number one, if you're saying that something is poorly designed, you're kind of in a roundabout way admitting that it was designed. So how would you know what poor design was if you didn't know what good design was? And, you know, as Christians, we know that the universe is not the way that God had it in the beginning. We're fallen. But also, how do you know the mind of the designer? I know, like, my students sometimes will try to figure out my lesson plans, and they can never see the big picture because they don't know why I've done things a certain way. And I think it's kind of that way with God. Also, with that objection, you know, why would the designer have all this wasted space where life could not exist? Wasted space is only if someone is constrained, but God is infinite. And not only that, but you can see I have a little gas tank up here. I heard somebody say once, is your car designed? Yes, it is. Is it possible to live in the gas tank? It wouldn't be very much fun. Just because you can't live somewhere doesn't mean it wasn't designed. And people look out and they see that the universe is huge, but before we knew that the universe was as massive as we know that it is now, people used to think that the universe was very small, and they would say, how could you believe in a God that is so weak that he could only make a universe as big as ours? So it doesn't matter what the evidence is, the skeptic is always going to have an objection. Universe is too little, God's weak. Universe is too big, God's too wasteful. Another one that you come across more when you start studying apologetics, some people will say we shouldn't be surprised that the earth seems designed for life. If the earth wasn't life permitting, we wouldn't be here to observe it. So they say you shouldn't ask the question because if the earth wasn't the way that it is, you wouldn't be here. William Lane Craig has a good illustration of why this fails. He says, imagine you're put on death row and you're in front of 100 trained marksmen and they are pointing their guns right at your heart. And they say, ready, aim, fire, and you hear the roar of the guns. And then you look up and you think, not only am I still alive, but I'm not even hurt. It wouldn't make any sense to say, I shouldn't ask why the 100 trained marksmen missed, because if they hadn't missed, I wouldn't be here to ask the question. It doesn't make any sense. It is kind of interesting how these scientists are always looking for reasons, but then sometimes when they kind of don't like the implications, all of a sudden they're like, well, we shouldn't really ask that question. So how do we know the Earth is designed? It resembles a known design. Think of like a biosphere with a bunch of dials. The Earth is kind of like that. The odds of it coming by chance are slim, and it serves the specific purpose of keeping us alive. Now, like I said, I think that this one, the weakness is that people know that there are trillions and trillions of Earth-like planets. For that reason, I think the fine-tuning is actually a better argument. The difference is, with fine-tuning, it not only applies to the Earth, it applies everywhere. So the fine-tuning argument says the fine-tuning of the universe is either due to law, chance, or design. It is not due to law or chance, therefore it is due to design. So what do we mean when we say that the constants of nature are finely tuned? There are certain values in the universe that are just so, and they're constant. They are the same anywhere you go in the universe. And so, for example, if we were going to calculate my weight on the planet Mars and your weight on the moon, we would use all different numbers except for the gravitational constant. That is the one thing that doesn't change in those equations. And so to better explain this, I have another short clip.
For centuries, the fact that we can discover things about the universe has really been something of a mystery. Why would beings like ourselves be able to discover a universe like this? Why is what we think about the universe, why would it correspond to the way things really are?
Our ability to discern and understand the universe is a fundamental part of what makes the universe tick, so that we're linked into it. This isn't just a sort of an accident, a trivial little byproduct. It is something that is linked to the great cosmic scheme of things. Now, I've no idea how that linkage works, why it's there, or anything of that sort, but I'm very, very struck by the fact that we can understand the universe in such exquisite detail and at such a deep level.
The spectacular progress of modern astronomy and physics is the product of a universe accessible to the human eye and mind. It is a universe governed by laws and forces that literally hold our planet Earth and the entire cosmos together, and are finely calibrated to allow for both complex life and scientific discovery.
If you didn't have something like gravity that pulled matter together, you would never get planets, you wouldn't get stars, you wouldn't get any complex organisms. If you didn't have the strong nuclear force, there would be nothing to hold protons and neutrons together in the nucleus. And so you wouldn't have any atoms, so no chemistry. If you didn't have the electromagnetic force, you would have no bonding between chemicals. You would have no light, and the list goes on. So you need all these sorts of fundamental principles have to be in place in order for life to occur. Wipe out one of those principles, wipe out one of those laws, no life.
During the past 40 years, scientists have determined the relative strengths of each of these primary laws and forces. These strengths are so critically balanced, they are often described as being finely tuned.
If you're to take the basic fundamental constants of nature and you were to change these even slightly, or you were to pick their values at random, you would almost never get a universe that would be habitable in any sort of way. That is, you couldn't have galaxies, you couldn't have planets, you couldn't have complex biological organisms if these fundamental constants were even slightly different, slightly stronger, slightly weaker than they actually are in this universe. That's the idea of fine-tuning.
To better appreciate this concept, imagine a machine able to control the strengths of each of the physical constants. If you changed, even slightly from its current setting, the strength of any one of these fundamental forces, such as gravity, the impact on complex life would be catastrophic.
If you increased it by a little bit, no large-scale life forms could exist. Anything that was more than the size of a pea would be completely crushed. So you might be able to get life of a very, very primitive sort, such as bacteria, but you could never get conscious observers.
Now, this is one of a long list of properties in underlying physics that seem to be prerequisites for a universe with life. For example, the strengths of the other forces are all important, the masses of the various subatomic particles. If all of these things were even a little bit different, then life, certainly life as we know it, could not exist.
These forces and constants are another example of the correlation between life and discovery. For not only are they finely tuned for our existence, they can also be understood.
It's remarkable how well the laws work. And not only that, it's remarkable how simple they are. And that also is related to the discoverability of the laws.
Albert Einstein wrote, "I have deep faith that the principles of the universe will be both beautiful and simple." For nearly 400 years, scientists have discovered an elegant simplicity in the mathematical equations that express and unlock the laws of the cosmos.
It's been said that many of the most important theories in theoretical physics can be written on a single sheet of paper. And this, I think, ought to be considered surprising, that such a simple formula or equation could have such far-reaching applications to a very complicated and very large universe.
What you have is a universe that is not only finely tuned for life to occur, but also has a beautiful, elegant mathematical structure, and a structure such that we can discover that structure.
Most scientists just take it for granted that the world is both ordered and intelligible. And the intelligible part I find really quite extraordinary, because it's one thing to accept that the universe is ordered, but ordered in a way that human beings are capable of understanding is an extraordinary thing. And so the question naturally arises, what is the explanation for that?
Now that is an intelligent design movie, but I know for a fact not all of those people that were interviewed are even believers in God, let alone Christians. But there was one guy in there who is a Christian. I mean, there are more, but one of the ones that were in that video, Robin Collins, he was the guy with like the curly hair and the beard. He's pretty cool, pretty well known in apologetics. He doesn't really have like a presence. He just kind of like works at a college, and then people use his work in their works. But he was interviewed in The Case for the Creator by Lee Strobel. That's chapter 6. And I just want to talk about one example from this. That's the force of gravity. This one's nice because we interact with gravity every day. But gravity is also what fuses hydrogen to create stars. It's a very specific setting. This is the example that's in our book. Geisler and Turk say that if the gravitational force were altered by 0.00037%, our sun would not exist. Now, Robin Collins, in The Case for the Creator, also talks about gravity. He says it's actually worse than that, because Geisler and Turk are just talking about the sun. Collins says, what would happen if you changed gravity? Just what would happen to our daily lives? He says, to wrap your head around this, you need to think of an old radio where you used to have to dial in the stations. You guys ever used one of those? And he said, imagine that every inch is a station. But instead of radio stations, those are settings that the force of gravity could have been. And he said that this radio dial would go all the way across the visible universe, billions and billions of light years. If you found the needle on that dial and you moved it 1 inch, you could have no animals much larger than insects. You could have no suns like ours, no earths like ours. And in fact, he said if you just moved it 1 inch, gravity, the force of gravity would increase 1 billion-fold. But if you could just increase it 1,000-fold, the largest planet you could get would be 40 feet in diameter. So we're talking a totally different place to live. Now, what does it mean to have a radio dial that goes all the way across the visible universe? Light travels at 186,000 miles per second. That's 7.5 times around the world in 1 second. Our nearest star is actually a star cluster called Alpha Centauri, and it takes light more than 4 years to get from Alpha Centauri to the Earth. If you were to go at the speed of light, the longest radio dial all the way across the universe, it would take you billions and billions of years to get to the other side. And it just so happens that that dial is in the 1 inch where it needs to be so that we can exist. You can't say that that's a coincidence. If there was just one example, I still wouldn't say that that's a coincidence, but I'd be like, man, that's cool, but I could see why people would deny that. Some people say, well, how many constants are there that are finely tuned? Some say, well, it's a dozen, but there are others that kind of grow out of those. So I'm just going to go with 30. Not all of them are quite as finely tuned as gravity, but gravity is actually not the best example of fine tuning. So the fine tuning is not by law. Why not think that it is due to law? I actually know the least about this because people usually don't argue this. I've never really heard someone say, well, it just had to be that way. And I don't know if this is a good illustration, but I think of like the ceiling in this room. If you woke up in this room and like had lost your entire memory, this was the only room you had ever seen, but you were an engineer, you know, you could take observations, you could figure out like what is holding the ceiling up, and you could do calculations to figure out, okay, if I wanted this room to be twice as wide, how would I do that? Even though you've never seen a room like that exists. I think that's how you can kind of like look into these constants. It's like you can't look into another universe, but you can do equations to see like what would it be like if we changed the force of gravity type thing. So why not think that it is by chance? Obviously, that would be kind of blind faith to just think that all this stuff came to be on its own by chance. It might be shocking to find out this is actually where the atheist goes. They say it's just by chance. So here's the theory. There are actually an infinite number of universes out there that we cannot sense in any way. Ours just so happens to be the one that got lucky. So if you have an infinite number of universes, parallel universes, at some point the odds are going to tip into your favor and you're going to have a livable universe. I cannot take this seriously. But this is what people believe, and this is trickling down to the popular level because I've had students try to tell me that this is how the universe operates. There are some problems with this. If you're going to say that there are an infinite number of universes that cannot be sensed in any way, what is the evidence for that? And the evidence is actually that our universe is finely tuned. I actually saw a little science, like a popular science channel, and someone was trying to give proof for these parallel universes, and they put a picture of the cosmic microwave background radiation, and they said, see that little dark spot on the picture? Maybe that's where our universe comes the closest to another universe. Seems strange. I mean, what couldn't you prove with that kind of reasoning? I thought to myself, maybe that's where the physical world and spiritual world come closest together. But I don't think that the atheists would like that. There is no outside evidence because you can't test another universe. Again, our friend William Lane Craig has a good illustration to show why no one really believes this. Because he said, imagine you're having a poker game with your friend, and every time this guy gets cards, he gets 4 aces. You deal, he gets 4 aces. He deals, he gets 4 aces. You take the aces out of the deck, and he gets 4 aces. You would probably accuse your friend of cheating. But what if your friend came back and said, no, you got this all wrong. There are an infinite number of universes out there. They're parallel. They're different. This just so happens to be the one universe where every time I deal the cards, or I have cards dealt to me, I get 4 aces. If you would not accept that for something as trivial as a card game, you shouldn't accept that for the universe. Plus, some people say, well, where do these universes come from? There must be some kind of universe generator, and that too would need to be finely tuned.
From galaxies and stars, down to atoms and subatomic particles, the very structure of our universe is determined by these numbers. These are the fundamental constants and quantities of the universe. Scientists have come to the shocking realization that each of these numbers has been carefully dialed to an astonishingly precise value, a value that falls within an exceedingly narrow, life-permitting range. If any one of these numbers were altered by even a hair's breadth, no physical, interactive life of any kind could exist anywhere. There'd be no stars, no life, no planets, no chemistry. Consider gravity, for example. The force of gravity is determined by the gravitational constant. If this constant varied by just 1 in 10 to the 60th parts, none of us would exist. To understand how exceedingly narrow this life-permitting range is, imagine a dial divided into 10 to the 60th increments. To get a handle on how many tiny points on the dial this is, compare it to the number of cells in your body, or the number of seconds that have ticked by since time began. If the gravitational constant had been out of tune by just one of these infinitesimally small increments, the universe would either have expanded and thinned out so rapidly that no stars could form and life couldn't exist, or it would have collapsed back on itself with the same result: no stars, no planets, and no life. Or consider the expansion rate of the universe. This is driven by the cosmological constant. A change in its value by a mere 1 part in 10 to the 120th parts would cause the universe to expand too rapidly or too slowly. In either case, the universe would again be life prohibiting. Or another example of fine-tuning. If the mass and energy of the early universe were not evenly distributed to an incomprehensible precision of 1 part in 10 to the 10 to the 123rd, the universe would be hostile to life of any kind. The fact is, our universe permits physical, interactive life only because these, and many other numbers, have been independently and exquisitely balanced on a razor's edge. Wherever physicists look, they see examples of fine-tuning. The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. If anyone claims not to be surprised by the special features that the universe has, he's hiding his head in the sand. These special features are surprising and unlikely. What is the best explanation for this astounding phenomenon? There are 3 live options. The fine-tuning of the universe is due to either physical necessity, chance, or design. Which of these options is the most plausible? According to this alternative, the universe must be life-permitting. The precise values of these constants and quantities could not be otherwise. But is this plausible? Is a life-prohibiting universe impossible? Far from it. It's not only possible, it's far more likely than a life-permitting universe. The constants and quantities are not determined by the laws of nature. There's no reason or evidence to suggest that fine-tuning is necessary. How about chance? Did we just get really, 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 really lucky? No. The probabilities involved are so ridiculously remote as to put the fine-tuning well beyond the reach of chance. So, in an effort to keep this option alive, some have gone beyond empirical science and opted for a more speculative approach, known as the multiverse. They imagine a universe generator that cranks out such a vast number of universes that, odds are, life-permitting universes will eventually pop out. However, there's no scientific evidence for the existence of this multiverse. It cannot be detected, observed, measured, or proved. And the universe generator itself would require an enormous amount of fine-tuning. Furthermore, small patches of order are far more probable than big ones. So the most probable observable universe would be a small one, inhabited by a single, simple observer. But what we actually observe is the very thing that we should least expect: a vast, spectacularly complex, highly ordered universe, inhabited by billions of other observers. So even if the multiverse existed, which is a moot point, it wouldn't do anything to explain the fine-tuning. Given the implausibility of physical necessity or chance, the best explanation for why the universe is fine-tuned for life may very well be it was designed that way. A common sense interpretation of the facts suggests that a superintellect monkeyed with physics and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. There is for me powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge.
So real quick, the last kind of argument is in the book. It is in chapter 5, Design as Biological Information. And basically this goes, they used alphabet serial in the book. I didn't have alphabet serial, but tiles will work. But they said, imagine you walked into the kitchen, and on the table, you saw these pictures. Obviously, you would know that the one on the right is designed, and the one on the left is just random. Not only because the one on the right is a little bit more ordered, but it contains information. It's telling you something. Take out the garbage, love mom. It wouldn't make any sense to say that that was just randomly there. Now in the 1950s, James Watson and Francis Crick discovered the double helix structure of the DNA molecule, and since then we've figured out that DNA is actually information. Information and language only come from a mind. DNA is not like a language, it is a language. Therefore, DNA came from a mind. Bill Gates has said that DNA is more complex than any software that we have ever thought up. Even Richard Dawkins, Mr. Atheist himself, said, biology is a study of complicated things that give the appearance of having been designed for a purpose. To which I think we should reply, Mr. Dawkins, maybe they appear to be designed because they actually are. Inside a single-celled amoeba, something that Charles Darwin would have thought was just the simplest life that you could possibly get, there's enough information in the DNA of a single-celled amoeba to fill 1,000 sets of the Encyclopedia Britannica. And then finally, the argument from discoverability. This is not in the book, but is in chapter 7 of The Case for the Creator. This is an argument that I've neglected because I just didn't really think it was that interesting, but it's starting to grow on me. So basically, this is the idea that not only is it very improbable to have a habitable planet, but it's very improbable to have a planet that is situated in such a way that you can discover things about the universe. And both of those improbabilities come together in the Earth. So, for example, there are certain things about our sun and about the stars in the universe that we would not know if we could not observe a perfect solar eclipse. So if you think about it, the three things you need for a solar eclipse: you need the sun, you need a platform with observers, in this case the Earth, and something to go in between the sun and the Earth, in this case the moon. Now, when the moon perfectly fits over the sun, we can see things about the atmosphere that we could never see otherwise. And that's actually what convinced Guillermo Gonzalez to start studying design, because he witnessed a solar eclipse and he said, isn't it interesting? The sun is 400 times larger than the moon, but the moon is 400 times closer than the sun. And they're both spherical, and they fit perfectly in the sky. Another good example is our place in the galactic arm. So I have a little visual aid here. This is the Milky Way galaxy. And like I said before, too close to the middle, you're dead. Too close to the outside, you're dead. You could live right here where this black pin is, but if you live in the arm of the galaxy, you wouldn't be able to see outside the galaxy. And so we live right here, not quite in the armpit, but not inside the arm. So when you look out at the night sky and you see the Milky Way, you are looking edge on into the plane of the galaxy like this. So not only can we see into our own galaxy, but we can also look this way and see out into the broader universe. I would suggest reading The Privileged Planet for that. Robin Collins also has an example. He says, electromagnetism is finely tuned. If it were a little bit too far one way, we would never have been able to have open fires. But open fires is how we got technology started. If it were a little bit more the other way, we could have never built up to having computers and transistors. So we're right in this range where technology can get started and we can build up to the computer age. How does that happen by chance?